Here we have a calculus problem. Okay, let's go to the information. A boy who is standing on a pole of height 14.7 meters throws a stone vertically upwards. It moves in a vertical line slightly away from the pole and falls on the ground. Its equation of motion in meters and seconds is x equals to 9.8 times t negative 4.9 times t square. The first question is find the time taken for upward and downward motions. Also find the maximum height reached by the stone from the ground. Okay, so first what we need to do is we have to draw a picture connected to the information we have. Okay, let me do it. Okay, let me continue. So this is a pole of height of 14.7 meters and this is the ground level. Okay, so now, so the boy is standing so on the pole and the height of 14.7 meter from the ground level, and it throws the stone vertically upward, and the stone goes vertically upward slightly away from the pole, and it reaches the maximum height over here and it comes back to the ground. Okay, so this is the maximum height. Okay, whenever an object is moving upward, so and when it reaches the maximum height, the velocity will become 0. So now from the equation of motion, there is x equals to 9.8 times t negative 4.9 t square. So we can find the velocity. That is by finding derivative of this x with respect to time, we'll be getting the velocity. So whenever we have equation of motion, and if I find the derivative of the equation of motion with respect to time, I'll be getting the velocity. And when I equate the velocity to 0, so that's a maximum height. So when I equate the velocity to 0, I can solve for t. Then that is the time the stone takes to reach the maximum height. So that's the time for upward motion. Okay, now what we can do is we can find the velocity. That is, let me take the equation of motion. That is x equals to 9.8 t negative 4.9 t square. Okay, now let me find the velocity. For that, I have to find the derivative of this x with respect to time. Okay, so v is equal to d of, now we can replace this x by the stuff which is equivalent to x, that is 9.8 times t negative 4.9 t square. Okay, so what dt, okay, v is equal to, when I find the derivative of this one, 9.8 it is a constant multiplied by the variable t, so we can keep the constant as it is. When I find the derivative of this t with respect to t, it will just become 1. Now I keep the constant 4.9 as it is. When I find the derivative of this t square with respect to t, I'm getting 2t. Okay, now let me simplify. So v is equal to 9.8 times 1 is 9.8. Negative, when I multiply this 4.9 and 2t, I'm getting 9.8 t. Okay, now I got the velocity. As I said already, so when the stone is thrown vertically upward, and when the stone reaches its maximum height, so the velocity will become 0. So for a fraction of a second. So if I equate velocity is equal to 0, then what I get? Then I'm getting 9.8 negative 9.8 t equals to 0. Now I subtract 9.8 from both sides. When I do so, positive 9.8, negative 9.8 will cancel out. I'm getting negative 9.8 t is equal to negative 9.8. Okay, to solve for t, I divide both sides by negative 9.8. When I do so, this negative 9.8, negative 9.8 will cancel out. So t is equal to, so when I divide negative 9.8 by negative 9.8, I'm just getting 1. Already we know that the unit of t is seconds. So it is 1 second. So when the stone reaches its maximum height, so the time is 1 second. That is, time taken for upward motion is 1 second. So time taken to travel this distance is 1 second. So now I got the time taken for upward motion, and also I have to find time taken for downward motion. How do you have to do that? Okay, once the stone reaches its maximum height, it will start coming down. So when the stone start coming down, so what will happen? And also one more thing we have to consider. So the stone is thrown from here at this point. So what is the height over here? What is the height of the stone at this point? So this is the starting point of the stone. At this place, the height of the stone is 0. That's the initial height. Okay, so here I'm not talking about the height of the pole. I am talking about the height reached by the stone at this position. So at this position is 0 because this is the position at where the stone is thrown vertically upward by the boy. Okay, so it reaches the maximum height, it will be somewhere else. Again, when the stone comes back and it reaches the point over here, which is corresponding to the starting point, again at this position, the height of the stone will be 0. Again, it travels some distance to reach the ground. So what distance it travel over here to reach the ground? Already we know that this height is 14.7 meters. So we know that this is the position of x equals to 0. So again, it has to travel 14.7 meters to reach the ground level. Then what is the value of x over here at the ground level? It is x equals to negative 14.7. So because this position is 0, x equals to 0. So since it comes down, the value of x will be negative 14.7. So the stone started moving from x equals to 0, and the final destination of the stone is x equals to negative 14.7. So now in the equation of motion, if I plug in x equals to this negative 14.7, I'll be getting the total time taken by the stone to travel from this position x equals to 0 to x equals to negative 14.7. Okay, let me do it. So I write the equation of motion, that is x equals to 9.8 times t, negative 4.9 times t square. Okay, now in this equation, I'm going to plug in the final destination of the stone, that is negative 14.7 for x. So negative 14.7 equals to 9.8 t, negative 4.9 t square. Okay, now, so I have to, actually it's a quadratic equation. I have to get this quadratic equation in standard form. That is ax square plus bx plus c equals to 0. So I need to have the square term, that is a t square term, the t term, on the left side, the constant, everything. On the right side, I must have 0. So for that, I have to subtract 9.8 t from both sides. Let me do it. And also I have to add 4.9 t square from both sides. Let me finish writing. So when I do so, this one will cancel out. I'm getting on the left side, I'm getting 4.9 t square, negative 9.8 t, negative 14.7 equals to 0. Okay, so here when I look at the quadratic equation over here, this one, everything is a multiple of 4.9. So but you can divide everything by 4.9, so to make the numbers smaller, so that it will be easier for us to solve the equation. So I have divided everything by 4.9. So this one will cancel out. 4.9 goes into 4.9 one times, and 4.9 goes into 9.8 twice. And here this is one times, and 4.9 goes into 14.7 three times. So I'm getting t square negative 2t negative 3 equals to 0 divided by 4.9 is 0. So now when I plug in the final destination x equals to negative 14.7 into the equation of motion, I'm getting the quadratic equation t square negative 2t negative 3 equals to 0. Okay, now I have to solve this equation for t. And also please remember that we have found time taken for upward motion, that is 1 second. That is a time taken by the stone to travel from the top of the pole to the maximum height is 1 second. Okay, now let me erase other stuff. Okay, now let's solve this quadratic equation over here. I think we can solve this quadratic equation by factoring. Okay, for that we have to consider the coefficient of the square term, that is t square. So it's a 1. So now we have to consider the constant of negative 3 over here. Since the coefficient of t square is 1, even if I multiply this 1 and negative 3, still I'm getting negative 3. Anyways, I can consider the constant of negative 3 over here. Now I have to get two factors for this negative 3, so that the product is equal to negative 3, and the sum of the two factors equals to the coefficient of t, which is the middle term negative 2. So I think negative 3 positive 1 will work. So to get the two values of t for this quadratic equation, so I just have to change the signs of these two factors. If I change this sign negative, then I'm getting positive 3 as one of the values of t. And if I change the sign over here, I'm getting t is equal to negative 1. So when I solve this quadratic equation, I'm getting two values for t. One is 3 and other one is negative 1. But t represents a time taken by the stone to travel. It cannot be a negative value. So we can reject this value because t cannot be negative, time cannot be negative. So here we get t is equal to 3. That means 3 seconds. Actually, I got this quadratic equation by plugging in the final destination of the stone into the equation of motion. So that means time that the stone takes totally 3 seconds to travel from this position x equals to 0 to x equals to negative 14.7. So the total time taken by the stone to travel the complete distance is 3 seconds. Already we know that the time taken for upward motion is 1 second. So the total time is 3 seconds. And what is the time taken for the downward motion? So clearly it's 2 seconds. So for a downward motion, so the time is 3 negative 1. So 3 is the total time from which I subtract the time taken by the stone for upward motion. So 2 seconds. Now I got the time for downward motion. So time taken for downward motion is 2 seconds. Okay, now we have done answering the first question. Okay, now let's answer the second subdivision. That is, find the maximum height reached by the stone from the ground. Let me erase the stuff we have over here. Okay, let's continue. Already we know that the stone takes 1 second time to travel from the top of the pole to the maximum height. So if I plug in t is equal to 1 into the equation of motion, I'll be getting this distance, that is from the top of the pole to the maximum height. But according to the question 2, we have to find the maximum height reached by the stone from the ground. So to find the maximum height reached by the stone from the ground, so we have to add the height of the pole 14.7 meters to the distance from the pole to the maximum height. Okay, now first let's find the distance traveled by the stone from the top of the pole to the maximum height. For that, I have to plug in the time 1 second to the equation of motion. Okay, let me do it. X equals to 9.8 times 1 negative 4.9 times 1 square. I just plugged in t is equal to 1 into this equation of motion. Then I'm getting x equals to 9.8 times 1 is 9.8. So the evaluation of 1 square is 1. 1 times 4.9 is 4.9. When I subtract 4.9 from 9.8, I'm getting 4.9. Already we know that the unit of x is meters. So the distance from the top of the pole to the maximum height is 4.9 meters. So to get the maximum height reached by the stone from the ground, we have to add the height of the pole to the distance what we got over here. So the maximum height reached by the stone from the ground is equal to, so that this distance from the top of the pole to the maximum height, that is 4.9 positive, the height of the pole 14.7. So when I add them, so I am getting 19.6 meters. So the maximum height reached by the stone from the ground is 19.6 meters.